Hey everybody, Mr. Barry here again with you, talking about vertex form for a quadratic function. We know that there's not as much information really quickly given to us as the intercept form, but we certainly can pull some things from it and then gather up enough other things using computation to get a good looking parabola here on this graph. So we're going to go ahead and start off doing this. We got y is equal to 3 times the quantity x plus 2 squared plus 4. So the first thing I want to do is recognize, obviously, that it's in vertex form. I want to pull out the vertex if possible, put that in my table of values, and start the process of getting the other 4 points afterwards. So I realize it's in vertex form. I want to go ahead and figure out what that h value is. Maybe you're taking a look at that parenthesis and you already know what it is, but just in case, we're trying to figure out what number would we plug into that parenthesis in order to get a number of 0. And we can go ahead and set up an equation for that. Subtract 2 from both sides, get x is equal to -2. That right there would be our h value for this problem. The back end here is 4. That's going to be our k for the problem. So here in this particular quadratic function, our vertex would be at the spot -2, comma 4. I'm going to go ahead and put that on the graph. -2, comma 4, right there. Next thing I want to go ahead and point out to you is our a value here is a positive 3. A value here is a positive 3. So because our a value is positive, we know we're going to have our parabola be going upwards. Kind of looks like a smiley face up there. And because it's going upwards, that means that our vertex is a minimum. So just to point it out here, this point right here is our vertex. So we're aware that it is going to be a minimum for this problem. Again, that might be something that we need later on when we do the application problems. Next up, I want to recognize the fact that we have a parabola here, as we well know, or we're going to have a parabola here, so that our vertex x value here is -2. That's a huge deal for us in this problem, because we know that that vertex x value will act as our axis of symmetry here. So that's our mirror in the problem. It wouldn't hurt you to draw it in. This is an imaginary line. It's not part of the graph. It's just nice to have here and use within the problem. So I mentioned before in the previous video that a good idea for the next 4 points, because we'd like to have a total of 5, is to pick x values that surround the vertex x value. So I have -2 right there. Numbers that are close to that, and I'm just going to go ahead and start off with the number -1. It's the one right above it, so we'll go ahead and start off with it. So we'll go ahead and try out x value of -1 here in this problem. It's going to involve a little bit of computation. Go ahead and plug in -1 to the problem here into the function. We've got to be careful to follow the order of operations, so I want to do what's inside the parentheses first. 1 squared is 1. 3 times 1 would be 3. Plus 4 would mean that we would have 7 as our y value when x was -1. So a y value of 7 when my x value is -1. I'll go ahead and put that on the chart here. We have -1 for 7. Or -1 comma 7, excuse me. There's 4, 5, 6, 7. There's a good spot right there for us on this table of values and on this parabola. Want to use that axis symmetry to understand the mirror. So I know we're in the negatives here with the x values, so this could be slightly confusing. But -1 is 1 spot away from the vertex, the axis symmetry, excuse me, -2. On the other side of that would actually be -3. Since that's 1 spot away and this is 1 spot away, we can say that the y values would be the same exact number. Feeling confident that's how the mirror operates here for us in this parabola. So I'm going to also put a point at -3, 7 right there. Now, there's a very, very good chance this next point, or these next 2 points, will be off the chart. We're going to do our best to draw the parabola. These things happen. This is kind of interesting here. In the previous video, we kind of avoided the y-intercept because it wasn't close. The x value, that 0, wasn't close to our axis of symmetry. And here it actually ends up being one of the points that we're going to plug in. So not only here are we going to go get a point, but we're also going to get the y-intercept. So we're kind of getting 2 for the price of 1 here. I'm going to take 0 and plug it in. Again, I got some computation to do here. Plugging in 0 this time for the letter x. Want to make sure we follow the order of operations and do things inside the parentheses first. Then do the exponent. 2 squared is 4. Then do the multiplication. 3 times 4 is 12. And we would add that to 4. And when our x value was 0, we would figure out that 16, not 0, 16 here would be our y value. I think our graph only goes to 12, so we do end up going off the graph. Nothing wrong with that at all. We can just try to estimate where that would be. But I do have a point here of 0, 16. 0 here, as we know, is a y-intercept that's on the y-axis. So this would be 12, maybe 13, 14, 15, 16. Maybe we'll put it right there, or at least try to make it look like it would go in the right spot right up there. We need a 5th point. We have 4 total. We want to go ahead and use the mirror here to go to the other side. So 0 is 2 spots away from our axis of symmetry, -2. On the other side of the mirror, 2 spots away would be the spot number for x value, -4. -4. And again, because they're equal spots away from each other, we would assume that their y values are the same exact number. So we want to go ahead. We could definitely plug -3 in and figure out that it's 7. We could plug -4 in and figure out that it's 16. But if we just understand how the mirror works, that's good enough. So I'll come over here to -4, and I'm going to kind of just again ballpark where that would be. Let's go with that right there. Try our best to connect the dots even though we're going off the graph. There we have it right there. Maybe not the world's best looking parabola, but we do know that we had the vertex. We got that right from the get-go. And with the vertex comes along the axis of symmetry, which is something that's very useful for us here because of the mirror. We had to do 2 computational problems, so we went ahead and we plugged in -1 first and solved and got that our y value would be 7. We did 0 second, which was nice because we got double the bang for the buck. And we were able to use the mirror to get the 5 total points with that. At the end, if you wanted to, you can always go ahead and go back, and I didn't do this in the last video, but you can go ahead and erase the axis of symmetry if you wanted to. If you left it in there during a graphing of a problem, obviously I know what it's going to be. But there you have it, the parabola for the quadratic function y is equal to 3 times the quantity x plus 2 squared plus 4.